In today's lesson, we will discuss vectors and vector addition. What are vectors? In the last two lessons, we talked about physical quantities such as displacement, velocity, acceleration, and so on. And we said each of these quantities, in order to understand each of these quantities, you need to know the direction. Displacement takes place from one position to another position. Velocity specifies the direction of motion of an object. Acceleration has the direction. So there are physical quantities. In addition to having a magnitude, what is the meaning of magnitude of a quantity? Well, if I say that I have two books in my hand, that two is the magnitude. Suppose I say the car got displaced 5 kilometers due east. That 5 is the magnitude, due east is the direction. So quantities that can be understood only by describing their magnitudes as well as direction are called vector quantities. What are some of the examples of vector quantities? Well, you know, displacement is a vector quantity, velocity is a vector quantity, acceleration is a vector quantity. Can you think of another physical quantity that is a vector? Suppose I say I applied a force on this object. Now, do you understand what I did with that force? No, you did not. You see, I can use a force to bend a wire, to stretch a wire, to squeeze a wire. Is that right? I can use a force to stretch a spring, to squeeze a spring. Unless I tell you in what direction I applied the force, the description of a force is not complete. Therefore, force is a vector quantity. It has magnitude as well as direction. So in this lesson, we are going to deal with vectors. How do we add more than two vectors or more than one vectors? When there are two vectors or three vectors, we will be able to add them to obtain a resultant vector. Alright, all these things we are going to do in this lesson. Okay, let's start. A vector is a physical quantity that has both magnitude and direction. Now, how do we represent a vector when you want to write a paper on it, for example? A vector is represented by drawing an arrow. Its length represents the magnitude and the arrow will represent the direction. For example, the displacement of an object from position A to position B is a vector. Let's draw a vector to represent the displacement of an object from position A to position B. This is an arrow from A to B. The length of the arrow represents the magnitude of the displacement. How much is the displacement? And the direction, how do we represent the direction? Well, if the distance measured from A to B is 2 meters, then the magnitude of the vector is 2 meters. So let's say the length of that vector is 2 meters. The direction of a vector is given by specifying the angle the vector makes with the positive x-axis. So whenever you want to draw a vector, always draw the x-axis, the positive x-axis. Here I have the positive x-axis and the angle measured. Remember, an angle can be positive or negative. the angle measured counterclockwise from the x-axis is a positive angle. If the angle is measured clockwise, it will be a negative angle. Is that right? So the direction of a vector is given by the angle the vector makes with the positive x-axis. There, the angle measured counterclockwise with the positive x-axis, and the angle is theta. Now the displacement vector makes an angle theta with the x-axis. So you can see the description of this displacement vector is now complete. We know its magnitude and we know its direction. Once you know the angle theta, you know the direction of that vector. The displacement vector has a magnitude 2 meter and its direction is specified by that angle theta. Okay, let's now talk about vector components. A very important concept, and pay special attention to it and learn that concept. What is the meaning of vector components? If this is a vector, vector AB, that vector can be constructed by two simple components. Let's talk about that. The displacement from A to B can be achieved by first moving from A to C along the x-axis and then moving from C. Look at this. First I can go from A to C along the x-axis and then move from C to B along the y-axis. You see that? A vertical axis is the y-axis, a horizontal axis is the x-axis. So a displacement from A to B can be achieved by first moving from A to C along the x-axis and then moving from C to B along the y-axis. That means vector AB can be obtained by adding vector AC to vector CB. Now I want you to understand that AC is a vector, CB is another vector. So if you add vector AC to vector CB, the result is vector AB. Now remember, there is a big difference between adding normal numbers or scalar quantities. We said quantities that are not vectors are called scalars. Is that right? We know 3 plus 2 equal to 5. Now, if I add the length of AC to the length of CB, do I get the length of AB? No, I don't. Well, I am not adding the lengths of the vectors, I am adding the vectors. In other words, the result of the vector AC and the vector CB is the vector AB. Adding vector AC to vector CB gives me the resultant vector AB. Or we say here vector AC and vector CB are the components of vector AB. And look at the vector equation. Vector AB, that arrow on top of AB says AB is a vector. Vector AB can be obtained by adding vector AC to vector CB. Vector AC is along the x-axis and it is called the x component of vector AB. So vector AC is the x component of vector AB. In a similar way, vector CB is along the y-axis, and therefore vector CB is called the y component of vector AB. Any given vector can be broken into an x component and a y component. For example, if I have a vector like this, look at that. If I have a vector like that, this is the x-axis. Now, it has this x component and this y component. Look at the way I construct. If this is a vector, then its x component is this and the y component is that. Any vector can be broken into an x component and a y component. All right, let's look at that one more time. In the right triangle ABC, AC is the adjacent side of the angle theta, is that right? And CB is the opposite side of angle theta. And AB is the hypotenuse. All right, let's now obtain values of AC and CB in terms of AB using a simple trigonometric relation. Now, you know cos theta is adjacent side divided by the hypotenuse. So cos theta is AC divided by AB. And therefore, what is AC equal to? AC is the x component of the vector. And what is AC equal to? AC equal to AB times cos theta. So AC equal to AB multiplied by cos theta. Similarly, sin theta equal to opposite side divided by the hypotenuse. Sin theta equal to CB divided by AB. Therefore, what is CB equal to? CB equal to AB sin theta. The magnitude of the x component is AB cos theta, and the magnitude of the y component is AB sin theta. Now, this is true for all vectors. For example, let me illustrate that with another example. Suppose this is my vector. What are its components? Its components are, that's the x component, and that is the y component. And let's mark the angle. What is the angle made by this? I'm going to call that vector A. Now, this is the name of this vector, vector A. This vector A has this x component and this y component. Now, what is the direction of this vector? The direction of this vector is specified by the angle the vector makes with the x-axis. What is that angle? That angle is this angle, and that is the angle theta. Therefore, what is the x component? Now, the x component is the vector times cos theta. So, this x component will be vector A times cos theta, and the y component will be vector A times sin theta. Now, you must be very clear about it. Whenever you have a vector whose magnitude we know and the direction we know, we can find the x component of that vector. If A is a vector that makes an angle theta with the positive x-axis, its x component will be A cos theta and its y component will be A sin theta. A very important concept. If V is a vector that makes an angle theta with the x-axis, then the x component of the vector is given by, can you tell me what that will be? the x component of the vector will be given by v sub x equal to v cos theta. What does v sub x stands for? The x component of vector v equal to v cos theta, and the y component of the vector is given by, how will I write it? It'll be v sub y equal to v sine theta. Okay, let's move on. Let's now introduce the concept of unit vector. What is a unit vector? A unit vector is a vector of magnitude 1. That's why it's called a unit vector. So if you now take the x direction and the y direction, we can have a vector of magnitude 1 unit along the x-axis. That will be a unit vector in the x direction, and a vector of magnitude 1 unit in the y direction. That will be a unit vector in the y direction. A unit vector in the x direction is a vector of magnitude 1 along the x direction. It is represented by the lowercase I and normally italicized. That's the very often. Now sometimes I italicize it, sometimes I forget. But that is the normal way to write a unit vector. So what does I stands for? I is a unit vector in the x direction. I is a unit vector in the x direction. It is a vector of magnitude 1 in the x direction. In the same way, a unit vector in the y direction is a vector of magnitude 1 along the y direction. And we will represent that by the lowercase j, again italicized. So the lowercase j is the unit vector in the y direction. So tell me, if I give you a vector, say a vector v equal to 5i, what do you understand by that? I'm giving you a vector v as 5i. What does I stands for? I is a vector along the x-axis of magnitude 1. If you multiply that by 5, you have a vector of magnitude 5 in the x direction. Alright, what does v equal to negative 5i represent? This is a vector of magnitude 5 in the negative x direction. Okay, we will be using all these concepts as we go on. A vector of magnitude 10 units in the positive x direction is 10i. 10i. A vector of magnitude 10 units in the negative x direction is negative 10i. Now I think that those numbers have gone off the screen. So what does 10i represent? 10i is a vector of magnitude 10 units in the positive x direction, whereas a vector of magnitude 10 units in the negative x direction is negative 10i. So this is positive 10i, this is negative 10i. Okay. So 10i added to negative 5i. What is the sum of these two vectors? 10i added to negative 5i. It's very simple to add because their directions are along the x-axis. This will give you a positive 5i. 10i added to negative 5i is positive 5i. You see, vectors can be added easily if they are along the same direction. a positive x vector and a negative x vector can be easily added. Similarly, a positive y vector and a negative y vector can be added easily. Also, two positive y vectors can be added easily. What is 5j plus 2j? You see, 5j plus 2j. Let me see if I can draw that here. 5j is this, 2j is this. If you add these two, you produce a vector of 7j. So 5j plus 2j, you see, 5j plus 2j is 7j. So it's easy to add vectors that are in the proper x and y directions. 8j plus negative 2j is 6j. Alright, let's do a small problem. Find the x and y components of a vector v of magnitude 15 units in a direction 30 degrees. You have a vector of magnitude 15 units in the direction 30 degrees. We need to find the x and y components of that vector. This is our vector of magnitude 15 units, and it makes an angle 30 degrees with the x-axis, with the positive x-axis. The 15 unit vector makes an angle 30 degrees with the x-axis. I'm going to call its x component as v1. You can also call it v sub x. Let's call it v1. Alright, tell me, what is v1 equal to? What is the x component of this vector? v1 will be this vector, and that will be given by, well, let's also write the y component. If v2 is the y component, this will be v2. So this vector has the x component v1 and the y component v2. Alright, let's find the values of v1 and v2. You know, in this triangle, v1 divided by 15 is cos 30 degrees. Therefore, v1 equal to 15 cos 30 degrees. And sine 30 degrees is v2 divided by 15. Therefore, v2 is 15 sine 30 degrees. So the x component of the vector is 15 cos 30 degrees, and the y component is 15 sine 30 degrees. The magnitude of the x component, now this is the magnitude of the x component, 15 cos 30 degrees. If you want to specify that this is in the x direction, what all you need to do is multiply it with the unit vector in the x direction. What is the unit vector in the x direction? The lowercase I. Alright, to indicate its direction, we multiply this vector with the unit vector I. Therefore, the x component is 15 cos 30 degrees I. Look at this, a very important information. A vector of 15 units at an angle 30 degrees with the x-axis has an x component 15 cos 30 degrees I. And what is the y component? The y component will be 15 sine 30 degrees j. And therefore, look at the way we write that vector v. If this is the vector v we have, this vector v is now written as the sum of its x and y components like this. It is 15 cos 30 degrees I plus 15 sine 30 degrees j. You can see I have forgotten to italicize these. So any vector that is given to you can be written as the sum of its x component and the y component. Okay. Now 15 cos 30 degrees is approximately 13. So this will be 13i plus 7.5j. You see, 13i plus 7.5j, you must understand it as, this is 13i, a vector of 13 units in the x direction, and this is 7.5j, 7.5 units in the y direction. So this is the x component, this is the y component, and if you add these two, you get the vector v. And what is that vector v? The vector v is joining the vector like this. Now, you see, a vector has a tail and a head. This is the tail of this vector and this is the head. For the second vector, this is the tail and this is the head. So once you have the components identified, to find the resultant vector, what all you need to do is join the tail of one component to the head of the second component. And this is the vector v. Alright. Now, I can actually use this to add any number of vectors. For example, if this is one vector and this is the second vector, I'm going to call this vector v and the second vector u. Now, can you tell me, if this is vector v and this is vector u, what will be the sum of these vectors? If you add these two vectors, what will be the result? The result will be the vector that is obtained by joining the tail of the first vector to the head of the second vector. Now, this is the sum of u plus v, and that is called the resultant vector. You see, actually this law is called the triangle law of vectors. If you got two vectors given by the two sides of a triangle in order, then the third side drawn in the opposite order will represent the resultant of these two vectors. Now, we will deal with more of triangle vectors in the lab part of this. At the moment, I'm going to leave this here. Okay, let's do another problem. Find the vector v that has an x component 12i and a y component 5j. Well, this time I have given you the components. You need to find the vector. The x component v1 equal to 12i. And let's draw this. This is the 12, v1 equal to 12i. The y component v2 equal to 5j. Where will I draw this? Draw that from the head of the first vector. There you are. So the y component is v2 equal to 5j. And therefore, what is our vector v? Our vector v is the vector drawn from the tail of the x component to the head of the y component. We are looking for the magnitude and direction of this vector v. Magnitude is the length of that line. Direction is the angle it makes with the x-axis. Simple, is that right? Alright, the magnitude of V can be obtained. Tell me, anybody tell me, how do we obtain the length of this vector? If you look at this right triangle, you can use Pythagoras theorem to obtain the length there. So we got V squared equal to 12 squared plus 5 squared. The length of this leg is 12. The length of the second leg is 5. So the square of the length of the hypotenuse we call V squared equal to 12 squared plus 5 squared, and that is 169. Therefore V equal to 13 units. This is the magnitude of the resultant vector V. We now need to find the angle. Anybody suggest to me how to find the angle this vector makes with the x-axis? The direction of vector V is given by the angle theta it makes with the x-axis. And how do we find that angle theta? The simplest way to find that angle is to take the ratio of the opposite side to the adjacent side. What is that ratio called? Opposite side divided by the adjacent side. It's called tan theta. Tangent of this angle is opposite side divided by the adjacent side. That is 5 divided by 12. And therefore, theta is tan inverse of 5 over 12. I hope you understand that concept. So, put in your calculator this quantity, tan inverse of 5 over 12. And keep your calculator in degree mode. Alright? And tell me what that is. Theta equal to tan inverse of 5 over 12. Keep your calculator in degree mode and calculate this. It should give you 22.6 degrees. Alright? Don't just sit back and watch this. You've got to be actively participating while you watch these lectures. Okay? So, we have now obtained that vector. That vector has a magnitude 13 units. Its direction is given by the angle theta equal to 22.6 degrees. So, very important concept. If you know the components of a vector, you can find the magnitude and direction of that vector. And conversely, if I give you the magnitude and direction of a vector, you can find the x and y components of that vector. Alright, let's do another one. Find the resultant of the vectors A and B shown in this diagram. Now, look at the vectors A and B. Let's talk about the vectors A and B. Vector A has a magnitude 10 units. It makes an angle 47 degrees with the x-axis. Vector B has a magnitude 15 units and it makes an angle of 110 degrees with the x-axis. Alright, can you write vector A in the component form? In order to add vectors, we first write each of these vectors in the component form. And how do we write vector A in the component form? Well, vector A has a magnitude 10. That means its x component will be 10 cos 47 and its y component will be 10 sine 47. Look at this. A is 10 cos 47i, this is the x component, plus 10 sine 47 degrees j. Alright? Any vector can be broken into x component and y component like this. And use your calculator to obtain this value. 10 cos 47 is 6.82 and 10 sine 37 is 7.31. So our vector A is 6.82i plus 7.31j. In the same way, vector B. Vector B has a magnitude 15 units. It makes an angle 110 degrees with the x-axis. Therefore, its x-component is 15 cos 110 degrees. Its y-component is 15 sine 110 degrees. Therefore, vector B in the component form is B equal to 15 cos 110 degrees I plus 15 sine 110 degrees j. And use your calculator, find the value here. That will be negative 5.13i plus 14.1j. Okay? We can now add these vectors. Let me draw these vectors for you over here. If you see our first vector, vector A, has the x-component 6.82i and the y-component is 7.31j. And vector B has its x-component, what is it? Negative 5.13i, and its y-component is 14.1j. So, you can now add the x-components together and the y-components together. You see? If both vectors are along the y direction, you can add them. So the y components can be added and the x components can be added. You can see 6.82i can be added to negative 5.13i. What will be the result? It will be a small positive vector. Similarly, 7.31j can be added to 14.1j. Alright, let's do that. So, the resultant, look at the word resultant. Resultant is the result of adding vectors A and B. And look at the way I wrote it. I took the i's first, the x components first. That'll be 6.82 minus 5.13i plus 7.31 plus 14.1j. So this is the x component of the resultant vector. This is the y component of the resultant vector. And that will be 1.69i plus 21.41j. We have now obtained the resultant of A and B in the component form. We need to find the magnitude and angle of the resultant. Let's do that. So the resultant vector has an x component 1.69i and a y component 21.41j. We need to find the resultant vector A plus B, which will be drawn from the tail of the first to the head of the second. This is the vector A plus B that we need to find. The magnitude of the resultant is, now tell me, how do you obtain the magnitude? The magnitude will be square root of this square plus, you see, square root of x squared plus y squared will give you the length of the hypotenuse. The magnitude of the resultant is square root of 1.69 squared plus 21.41 squared, and that will be 21.48 units. The length of the resultant vector is 21.48 units. What is the direction of this vector? How do you find the direction? Well, the direction of the resultant is given by the angle theta here, and tangent of that angle theta is y over x. Y is 21.41, x is 1.69. So tan theta equal to y over x. Remember, we are talking about theta, this angle. Tan theta equal to y over x. That is 21.41 divided by 1.69. And you can now, if this is tan theta, theta will be tan inverse of this. So in your calculator, go and punch this in. Tan inverse of, use a parenthesis. Tan inverse, I think most calculators come with a parenthesis when you type in tan inverse. 21.41 divided by 1.69, parenthesis closed, and what does that give you? That is 85.5 degrees. So the result of adding those initial two vectors is a single vector that has a magnitude of 21.48 units and an angle 85.5 degrees.